we're going to be doing some radicals. So last week we were learning about the exponents, and this week we are going to learn about radicals. All right, so this is lesson 2 of this unit. So first we're going to, of course, go over the homework questions, review what we learned before, and go over radical rules. So I'm just going to give you guys a couple of moments to do this homework problem, and I'll explain it afterwards, okay? So just quickly post your answers for the homework. If you don't know, just wait patiently, I'll explain it. All right, so William says a squared times b to the -5th. All right, William, make sure you don't have negative exponents in your answer because they're not simplified enough. So remember, when you have when you're simplifying these, you need to have positive exponents. So make them fractions. Okay, William, how would you solve this?
So at first, just since A and B both have the same base, like there's the same base on both of them, then I just do 0 minus 6 to get A to the power -6 times B to the power of 15. And that all to the power of a -1/3. And after that, I just multiply all the powers by -1/3 to get A to the power 2 times B to the power of -5, which is equal to A to the power 2 over B to the power 5.
Very good. Great job. Okay, so before I go on, I just want to mention this fraction exponent because I forgot to do it last time, or we didn't have time to. We won't be using fraction exponents that much, but you will later on if you learn more advanced mathematics. So the fraction exponent, a over m, a to the m over n. Well, how about let's just do a to the 1 over n first. A to the 1 over n is the nth root of a. All right, do you understand? Okay, so a to the 1 over nth power is the nth root of a. For example, 2 to the 1/2 power, which is equal to the square root of 2, and 2 to the 1/3 power is equal to the cube root of 2, right? Now, then how do we figure out what m over n as an exponent is? Well, first you kind of have to separate it, right? So this is just equal to a to the 1 over n times m, or like this, you write it as a to the 1 over n to the n power. Then you can see that it's obviously the nth root of a to the m power, like this. That is what a to the m over n is, and that's all you need to know to understand. All right, so William, do you understand that?
Yes.
Okay. So it isn't too hard, and we won't be working with it too much, but that's basically what a fraction exponent is. Now let's go to number 2. Okay, just put your answers in the chat. All right, let's do this problem. All right, how about Kaylee this time?
Okay. First I simplified the fraction inside the parentheses, so it would be y to the negative 10th to the second power.
Right, because you can just cancel out the x's, right?
Yeah. And then that would be y to the negative 20th. And that is 1 divided by y to the 20th.
All right, very good. Okay, let's do this last one. All right, let's look at this problem. So William says 1 over x to the fourth, y to the third. Let's get someone else this time. How about Ethan? All right, Ethan, I think you turned in your homework. So let's see how you did on this one.
So first I subtracted x to the negative fifth by x to the negative four. I mean, the exponent by negative four, so that is x to the negative first. And then for the y, I got y to the negative fifth, and that's to the exponent of fourth. So I distributed that, and I got x to the negative fourth times y to the negative 20th.
All right. Okay, so we can't have negative exponents, right? So what do you do now?
So we get the reciprocal of it.
Very
So
good.
I think it's x to the fourth times y to the 20th.
All
And
right, really good. All right, so it's very easy. You just flip the fraction if it is a negative exponent, right? Okay. And remember, you can't have negative exponents because that's not simplified enough. Now let's go on to a review of the simple principles. So I'm just going to call out, okay? So does anybody remember what is anything to the 0th power? Okay, what is it? All right, you can just type in the chat real quick. So everybody, what is that? Anything to the 0th power? Yes, it is 1. All right. Okay, very good. It's 1. So a to the 0th is always 1. How about a negative exponent? Okay. So can anybody explain what happens when you get a to the negative n, assuming that negative n is negative? What happens when you have a negative exponent? It's just 1 over a to the n. Very good. All right, Kaylee, very good. Okay, and also William brought up a very good point. A to the 0th power is equal to 1 if and only if a does not equal to 0. Very good, William. Let's add that a cannot be equal to 0 because 0 to the 0th power is just going to be undefined. It's undefined. Okay. So make sure that a is also not equal to 0. But we don't usually have to worry about that much. Okay, and simplifying, what you need to do is what happens when you have a to the n plus a to the m. How do you combine those two exponents? Well, not plus. What is it? It's multiply. What happens when they are multiplied together? How do you combine them? So how would you combine a to the n times a to the m? All right, they have the same base. So therefore, we can combine them like a to the m plus n, right? Similarly, how would we do a to the n divided by not b, by a to the m? Now it's divided and they still have the same base. So what is it going to be equal? All right, just put your answer in the chat. Yes, so it is a to the n minus m. It is a to the n minus m. Okay, so a to the n minus m. And you have to remember these exponent rules for when you simplify. Okay. So now let's circle back and review why why a to the 0 is 1. So how about William? Okay, William, could you help with this one? So last lecture I talked about why a to the 0 is equal to 1, and we can actually prove that using the negative exponents. Well, not yeah, the negative exponents and also the simplifying. All right, so how would you prove that a to the 0 is equal to 1? Do you have any idea?
Yeah, so if you do since a to the power of just say a to the power of 3 divided by a to the power 3, that will be a to the power 0 because you subtract the exponent numbers. But a to the power 3 over a to the power 3, if a is not 0, it cannot just equal to 0 because it has to be multiplied by something. So it's 1.
Okay, so I think you get the idea. So what we want to do first is I like how you brought up example of 3 and -3, and that's exactly what we're going to do, right? So because using the simplifying this product rule of exponents, what we can do is, since 0 is basically like 1 minus 1 or 3 minus 3 or 4 minus 4, right? And we can use this inverse exponent thing. Okay, since a to the 0 is just equal to a to the n times a to the um it's just going to be a to the n times a to the negative n, because if you simplify it, this is just equal to a to the n minus n, which is equal to a to the 0. Now, with that being said, we can look at this negative exponent here, and we can see that it is just you just take the reciprocal, right? Because here this is just 1 over a to the n. So a to the 0 is equal to a to the n over a to the n. What is that? Something divided by something is something, and divided by the same thing is just going to be 1, right? Since they're not 0, okay? So that is how you prove that a to the 0 is equal to 1, using both this simplifying rule and the negative exponent rule, which is quite nice, okay? So that's how you do it. So now let's review a couple more principles. So I'm gonna have a couple people help me with this. Well, actually, no. Everybody can just type in the chat, okay? So when you have a power to a power, for example, like a to the n and all of that to the m, what is the result? How would you simplify this? All right, just type in the chat your answers, okay? How would you simplify that? All right, let's look at the chat here. Okay, so how would you simplify? So a to the n times n, very good. So when you have a power to a power, all you're gonna do is just a to the n times m here, all right? It's just the product of the two exponents. Now, how about a product to a power? ab to the nth power. Now, what would this equal if you were to multiply it out and everything? All right, let's look at the chat here. So it's just going to be a to the n times b to the n. Very good. So what you're gonna do is kind of like distributing something, distributing the exponent, right? So all you gotta do is distribute the exponent to each of these objects in this product, right? A to the n times b to the n. Now, you can't do this with a sum, right? This doesn't work because you can't do a to the n plus b to the n like this. It doesn't work. This is not true, so do not do this. You actually have to multiply it out. Okay, now quotient to a power. Didn't have this last time, but I thought it's pretty similar to product to a power anyways. So something like this, right? Quotient to a power. And so what would this equal? It's very similar. All right, so let's see. Yes, so it's just going to be a to the n over b to the n. Okay, very good. Like this. All right, so very simple stuff. Now let's learn something about radicals. So what are radicals, right? That's just n to the nth root of a. Those are what radicals are. So what is the nth root of a? So the nth root of a is, this is basically the nth root of a multiplied by itself n times is equal to a, okay? So I'm just going to let you think about this definition for a bit, all right? The nth root of a multiplied by n times should be equal to a. For example, 2 cubed is equal to 8. So therefore, the cube root of 8 is equal to 2. Think about it, right? So if you think about it, the cube root is just the inverse of cube, right? Just like how the square root is the inverse of squared, right? And so on. For example, the fifth root is the inverse of multiplying something to the power of 5, right? So with that in mind, let me just give just a short example, right? So what is how about this? What is the fourth root of 81? All right, what is the fourth root of 81? Okay. All right, and Kaylee and Michelle say 3. Very good, very good. So the fourth root of 81 is just 3 because from this definition, the fourth root of 81 multiplied by itself 4 times should just be equal to 81. And it's just going to be 3 multiplied by itself 4 times. It's going to be 81 because this is 9. This is 9. 9 times 9 is 81. All right. So that is just a quick example. Now about principal square root. So William, I want you to help me on this one. Okay, William. So William, so this is 4, right? So what is the square root of 4?
2.
But would -2 also work?
Oh yeah, yeah. -2 or 2.
Well, you see here, the thing about this is the principal square root. Now, it doesn't really apply to like other roots, right? But the principal square root says that when you're just taking this the regular square root of any number, it says that it has to be positive. So even though there's a common misconception that the square root of 4 is equal to plus or minus 2, it's not. It's just 2, because you can look at it this way: the principal square root of 4 is just equal to the square root of 4. The negative, where do we get that -2? That's just negative the square root of 4, right? So when you get principal square root, make sure you use absolute value or make it positive, right? Principal square root is just 2, not -2. If you plug it into your calculator, it's not going to say like plus or minus 2, right? And if you go on any online calculator, plug it in, square root of 4 is just 2, right? However, don't be don't like mistake this with another misconception. X squared is equal to 4. Now this x is equal to plus or minus 2. Why? Because what you're essentially doing is you're taking the square root of x squared, which is actually equal to the absolute value of x. But we're not going to get too much into that today. I just want to introduce the principal square root, make sure clear up this misconception that the square root of 4 is equal to plus or minus 2. It's just 2. Okay? Do you understand, William?
Yeah.
Okay. So now let's go over the product and quotient rules. The product and quotient rules, it's very similar. Actually, yeah, it's pretty similar to the exponent rules, because exponent also have like the product and the quotient. So there's special things with the products and the quotients of radicals. So now we know what a radical is. It's basically a root. A radical is just a root. And what you do when you multiply two roots of the same, let's say same, I don't know what it's called for a second. Hold up, let me okay, there we go. Okay, it's called the index. All right, so let me show you for a second. Forgot for a second. So when you have the square root of x, and for example n is here, all right, this is called the index. You don't really need to know this, right, the exact names, right, but I'm going to use it to explain this. So this is called, the n is called the index, right? For example, a cube root, the index of a cube root, that's going to be 3, right? And the radicand is a number inside the root. All right, very pretty straightforward. All right, so let me just explain this with these terms. Okay, now you know what these terms are. So the product rule. Okay, so let's say we have the square root of 4 times the square root of 4. What you can do is, with the product rule, you can actually no, that's a really bad example because you can just simplify that. How about this? The square root of a times the square root of b. This is just going to be equal to the square root of ab. Think about it. As you can model it with actual numbers, and you'll see that it is true. For example, the square root of 2 times the square root of 2 is just going to be the square root of 2 times 2, which is square root of 4, which is also 2. Well, you can model it, right? So the product rule states how you can combine these radicals, but if and only if the index is the same, right? So we see a very common, a similar commonality here, right? When you multiplied exponents, you could only combine them when there was a similar base. And similarly, when we're working with radicals, you can only combine radicals like this when they have a similar index. In this case, they're both square roots. You can't just combine like a cube root and a square root. That wouldn't make sense, right? So you can only do it with the same like square root, or you can only do it with 2 fourth roots or 2 fifth roots, right? Okay, now the quotient rule. Okay, this is more like kind of like distributing the square roots this time. So it's actually really similar to just kind of like distributing the square root. So when you have the square root of a over b, it's very simple. It's just going to be equal to the square root of a over the square root of b. Okay, it's very simple stuff, right? You kind of just distribute the square root, right? Now let's go to simplifying a radical. All right, so this stuff, it's going to be pretty hard to understand at first, but once you work more with it, it'll be very easy, okay? So first, let's simplify the square root of 8. Very easy, right? Well, not yet, because you realize that 8 is not a perfect square. So how are you going to simplify? It's not like 4 or 9 when you can just simplify. Okay, so how about Kaylee? Could you help me on this? So, Kaylee, what are 2 factors of 8?
4 and 2.
Very good, 4 and 2. And we needed those rules. We needed the product rule earlier to do this. So technically, the square root of 8 is made of the square root of 4 times the square root of 2, right?
Yeah.
So then you see there's square root of 4, which is a perfect square. And that's just going to be equal to 2 times the root 2. All right. If you simplify the square root of 8, it's just going to be 2 times root 2. So what the key to simplifying a radical is to find the perfects in there. Now I don't say perfect squares because we're not gonna be working with square roots anymore, right? You can also have cube roots. So let's just do one more square root problem and then let's try one with the cube root. It'll be the same idea roughly. Okay. So let's try with how about let's say we have actually yeah, how about 54? Yeah, how about let's do 54, okay? So try to spot a perfect square in this. All right, you're trying to spot a perfect square.
9.
So first, right? Very good, very good. 9. First, you just gotta find factors, right? And the easiest way to do this is actually prime factorize it if it's very big. But obviously, 54 is still comparatively pretty small number we're working with here. So we can just find factors pretty easily. So it's just going to be equal to the square root of 9 times the square root of 6. Okay, like this. And that's just going to be equal to 3 the square root of 6. Now, before we go any further, what we're going to do is let's work with some variables now. So this is obviously a square root, 8x to the 4th and y to the 3rd. All right, so first, Kaylee, we obviously know that, let's just split it. Let's just split it into this. Okay? Now, usually, what I encourage you to do is to draw a little tree like this, such a little tree diagram. I don't know what it's called, but it looks, when you do the prime factorization, that's what it's called. But that's what it looks like. So usually I encourage you to do that, and it's very effective when learning it. But once you get used to it, you don't really need it anymore. But first, let's just do that. Okay, so we already know that the square root of 8 is going to be equal to what?
2 and the square root of 2.
Very good, very good. Okay. So now that we got that figured out, we don't need to worry about that anymore. We'll just multiply it when we're done. Okay. So now, how about, let's just look at x to the fourth right now. What about x to the fourth? Can it be directly square rooted?
Yeah, because it's x.
Yeah.
It's x squared to square.
Yeah, it's just x squared, right? X to the fourth is just x squared. Now, how about y cubed? Can it be squared? Or square rooted?
Yeah.
No,
'cause
but you
y.
can simplify it.
Yeah.
So how would you simplify? How would you simplify?
It's y and then the square root of y.
Very good. Very good. Okay. So if you look at this, the square root of y cubed is actually going to be equal to the square root of y times the square root of y squared, right? Which is just going to be equal to this y times the square root of y, right? Because this is equal to just y. Now that we've got that figured out too, let's just do it. Okay, you just combine the ones that are not in the square roots together, 2x squared y, and then combine the square roots together. It's just going to be 2y. This is very simple stuff. Okay.
Okay.
So now, before we actually do, before we go on to practice problems, I want to introduce you. What if we're not working with square roots? What if we're working with like a cube root? All right. So let me just make up a problem real quick. So problem. Okay. How about 27? Maybe that'll be fine. So actually, think about it. Oh, let's make it 81. That'd be funny. Okay. 81 times x to the 7th, y to the 6th. All right. So now let's do it. Okay. So, Kaylee, again, what is the cube root of 81? Now you simplify it very similarly. You simplify it very similarly. Instead of trying to find perfect squares now, you're trying to find perfect cubes. So what's the cube that's a factor of 81? It's 27, isn't it? It's 27. It's the cube root of 27 times the square root of 3, of course, or cube root of 3. Okay. So then what do you get?
3 and the cube root of 3.
Good. Okay, so it's just the 3 and the cube root of 3. Okay, very simple. Now let's do the hard stuff. Well, not really hard. It's good when you understand it. X to the 7th first. What is it made of?
It's made of x
X to the 6th and x to the power of 1. Yeah.
Very good. Very good. Okay. So what can you do? All right, when you have, see, what you need to do is you need to find the exponents that are a multiple of 3. That means they can be cube rooted, right? So then what is the cube root of x to the 6th?
X squared.
Very good, because x squared cube is just x to the 6th. You got to think backwards, kind of, right? And we just have the cube root of x here. Okay, and finally, y to the 6th. It's really easy because it's just going to be equal to y squared, right? And that's perfect cube. And then we combine everything, x squared, y squared, right? And then combine the things inside the cube root. It's just going to be equal to 3x squared times y squared, all right? And then times the cube root of 3x. All right, so very simple here. It works the exact same, right? When you have a cube root. So now we can do some practice problems. All right, so I'll give you like 5 minutes to get it together and like get your answer. Okay. So, and I'll go over it later. Okay. So 5 minutes, a couple moments, and put your answers in the chat. All right. So let's see. So our answers, right? First, what we got to do is, separate the 8, right? We already know what that is. And that's just going to be equal to 2 times the square root of 2 because we already solved that before. Now let's look at x to the 6th. Now, this is a really easy problem because all of these exponents are even. That means they're all perfect squares. So the square root of x to the 6th is just going to be equal to x to the 3rd, and the square root of y to the 8th is just going to be equal to y to the 4th. So as long as you have even exponents, you don't have to worry about too much, right? So it's just going to be equal to 2x cubed y to the 4th and the square root of 2. So quite easy. Let's see if everybody got that. Yeah, okay, very good. Now let's go on to this problem. So make sure you know to like combine like terms, okay? All right, so let's look at this 1, 2. Okay. So what we need to do first is to look at these two multiplied together. Well, because of the product rule, we can actually combine these because they have the same index, which is 3. So the cube root of 8, which conveniently is just 2. It's just -2, right? And this is going to be 2 times the cube root of 32. Well, the cube root of 32 it's just going to be equal to the cube root of 8 and the cube root of 4, right? So then this is equal to 2. It's just going to be equal to 2 times 2, 4 times this cube root of 4 minus 2, like that, okay? All right, so very good, very good. And that is all we're going to have time for today. So thank you for listening. I'll see you next week. All right. I'll post the recording and the homework soon, okay?
Bye. Have a great week.